Thank you for having me here at this Google Developers meetup of Washington, even if it's just online, but hopefully it's going to be interesting for you. And hopefully you're gonna learn something that you didn't know before. So the topic of today is D-KMP Architecture, where D stands for Declarative UIs and KMP stands for Kotlin MultiPlatform. And then we are adding an extra sauce, which is the MVI pattern, which is what we believe is what makes the two, Declarative UIs and Kotlin MultiPlatform, work best together. So my name is Daniele Baroncelli, and hopefully we're gonna walk through this presentation. Hopefully it's not gonna be more than 45 minutes. I'll try to keep it to the point as much as I can. I have 40 slides, so hopefully one slide per minute. So let's start. So far, yeah, like if we take the perspective of what apps development has been in the past, we definitely can see that in most cases there has never been like a shared code. So if you wanted to develop Android, iOS, and web apps, you had to develop 3 distinct apps, 3 whole apps that would share nothing. But that also means 3 times bugs and a lot of effort of development. So we believe the future, and we don't only believe because we prove it, that is going to be much, much different. And we are presenting today this D-KMP architecture, where we are going to explain that we are able to explain 85% of the code, where this 85% is the business logic, which is written in Kotlin MultiPlatform, and the 15% is the UI layer, which is the only, that's very important to focus on this, the only platform-specific part of our app. So anything which is not UI is possible to be shared through Kotlin MultiPlatform. And if you see, like in terms of effort, code efforts, there's a lot of difference. It's less than half. So let's explain which are like the main topics, the main elements of D-KMP architecture. So in our D-KMP architecture, we have the business logic and the UI, which are fully decoupled. So they're completely distinct domains, which are still able to interact very easily with each other. You only share the business logic, but that's the biggest part. And we have proved that we've already developed 2 apps with this architecture, and we definitely can prove that we were able to have 85% of shared code. And but by not sharing the UI, so this is a very important point, what I'm talking about now. So by not sharing the UI, you grant yourself the flexibility of targeting any kind of device. So if we look at back to the diagram, so as you see, we are sharing, in Kotlin MultiPlatform, the business logic, but so this is the only, so this business logic that we are sharing, then we are able to apply to any UI layer. So if new device, so at the moment in the diagram you see Android, iOS, and web, but if, you never know, like if a new device or a new iOS or a new UI toolkit comes out, you're still able to use this 85% for this other device or the operating system. This is very important because if we compare it to Flutter or React Native, this is not going to be this is not like that, because Flutter and React Native, they're very opinionated in terms of UI. So they have their own UI framework, which in case of D-KMP, we don't have. So this means that if a new platform or new device comes out and we want to reuse or the code that has been written, you are not able to do that in Flutter and in React Native. So this is a very important point, which is a very important selling point of KMP in general, because this is really the main difference between Flutter and React Native. There are other differences, and we're going to show it, but this is very important difference. The ability, the flexibility to use any UI toolkit with that. So let's go through the 3 pillars of our D-KMP architecture. So declarative UI. So why declarative UI? So something happened. Is been happening at the moment in both mobile framework, in Android and iOS, where the traditional UI toolkit is being replaced effectively by a new toolkit. And this toolkit is a declarative UI toolkit. So in case of Android, it's JetpackCompose. In case of iOS, it's SwiftUI. Then the second pillar is Kotlin MultiPlatform, which is a multi-platform technology that finally makes sense and works. And then the third pillar is the MVI pattern, which is based on unidirectional data flow and a single source of truth for the app state. And a very important thing is that usually this MVI pattern is coming from Android, like originally, is mainly adopted in Android, and is based on RxJava. So in our D-KMP architecture, we are able to show that we are very simply able to apply the MVI pattern without RxJava by using something which is part of the Kotlin language, but most importantly, it is multi-platform. So it works wherever Kotlin works, and at the moment it's kind of everywhere, really. So, but then I'm going to talk about the foundation of these guys. One of these guys, Kevin, is also, I've seen, is in this presentation, so I say hi to him. So these guys are the ones who have written a lot of things, and they have made a lot of webinars on these topics, which are MVI, Kotlin multi-platforms, declarative UIs. And so this presentation today is about connecting the dots of these three main topics, and to actually present an architecture which makes sense and it is actually practically works. And so let's go on because there's a lot of content. So let's start with a very, generalization of what app development has been typically in the past, and what and how is going to be in the future using the architecture that we are proposing today. So in the past, we had imperative UIs, as we say, so like the traditional UIs, like the current Android-based system, and in iOS we have interface builder, storyboard. This, I'm talking about this. You commonly call them imperative UIs now to differentiate them from these declarative UIs. And to connect the layout of the imperative UIs to the view model, you always needed an extra layer of codes, which I'm going to explain later specifically. So one of the main interesting, aspects of declarative UI is that you don't have any extra layer codes if you want to connect the data that's just coming from the view model to the UI layout. And they are really decoupled in a very neat way. And this is definitely a very important difference between the imperative UI layout, UIs and declarative UIs. And so talking about the differences, before we used to share in general, so I'm talking about not everyone. So there are cases where apps, they try to share stuff, not very successfully, even on the client side, but not really, successfully. So typically in the past, apps, they used to share mainly the web services. This was like the main code, which was definitely shared between all platforms. So in the future, we are going to have a situation where we are not just sharing the web services, as is obvious, but we are going to share both the view model and the business logic. So let's summarize. So in the past, you had UI layout and view model, which required a coupling middle layer. In the future, you're going to have the UI layout and the view model, which is fully decoupled. We're going to explain this properly later. We are just stating now some of the things. So in the past, you didn't have any shared code in the client. And in the future, you're going to have 85% of shared code in the client. So in the past, you tend to use patterns like MVCs, MVP, MVVM. And in the future, it makes a lot of sense when you deal with declarative UIs and Kotlin multi-platform to use MVI and to use its characteristic, which is the single source of truth for the app state. And another very important difference, and this is where we are going to talk about this, because it's really, in my opinion, what really makes a lot of sense. I mean, the distinction that is really going to be very important in the future. So the concept of rich client. So in the past, we tend to have thin client, because any logic that you applied on the client had required replication. So you had to replicate for each platform. So this really made apps to be, to have as smallest as possible business logic, unless it really provided like a very important advantage in terms of user experience. But it tended to be thin. We tended to architect it them thin. So with a multi-platform architecture in terms of the client, now we have really the advantage of developing some rich client, and that means we are really going to have amazing app, which an amazing, because it's going to be really inexpensive to write client-side logic. So this means that we are going to really able to do amazing things, whose aim is always the user experience. So this is a very important concept. The rich clients, that is going to be much easier. I mean, it's going to be much rich, the client, so it's going to have much more logic than the past. So let's state something important about this KMP architecture. So this architecture is aimed at greenfield projects. So it's not about gradually introducing declarative UIs and KMP to existing projects, because so we are actually talking about an architecture which is clean, solid, and future-proof, which makes not compromises with the past. So this is a very important assumption, because KMP on its own can be used in many different ways. And there are many people who might be interested in making multi-platform just a single module of an app and to share it between different platforms. But we're going to talk about really something, advanced here, something very clean, and let's see. So, okay. Talking about the first pillar, declarative UIs, let's show some kind of timeline. So what is declarative UI? So declarative UI is something that became popular on the web thanks to React.js, which is a framework created by Facebook in 2011 and open source in 2013. And then it was brought to mobile with success by React Native, which was like the mobile version of React. I'm not going to go much in detail because I expect you know a lot of things about this. And Flutter. So Flutter probably has been really what made declarative, what is really what showed that declarative UI made a lot of sense on mobile, because it made development much easier comparing to the traditional view-based systems. So then in May 2019 at Google I/O, Google presented its own new toolkit, declarative UI toolkit, which is JetpackCompose. And in June 2019, at Apple WWDC, Apple presented SwiftUI as the new declarative new UI toolkit for Apple, which is also declarative. So some characteristic of declarative UI. So they just describe how the UI looks like for the different app state, but they are stateless, so they don't manage the app state directly. And the UI layer is neatly decoupled from the view model, as we showed earlier. So this is, we can really talk about, you show here about this middle coupling middle layer that we were talking before. So this is an imperative UI toolkit. So namely like the current Android view-based system, and in iOS, the interface builder. So as you are all Android developers, you know very well that when you design a layout, which you do it in XML, you always need some kind of code to apply the data to such layouts, and typically by using find view by ID, even though recently with the view binding, this has made much simpler, but still even with view binding, you still have this extra layer of code, which is maybe not as boilerplate as before, but still it's there. And in iOS, you have a very similar concept. So you have the layout that you design in Interface Builder, but then in the code, you still need to reference each element of the layout in order to apply the data to it. So in Declarative UI, as you see the difference, there is not this layer at all. So the data you can apply directly on the layout. And the same happens in Android with JetpackCompose and in iOS with SwiftUI. This is a very important fact because you are going to remove a lot of boilerplate in this way. And this is also the reason why the UI layer can be so thin, because it just has the information that really matter, nothing else. So let's talk about JetpackCompose in Android. So it was announced in May 2019 at Google I/O. In August last year, it reached alpha, and then we expect it should reach beta in the second quarter of 2021 and stable in the fourth quarter of 2021. It requires only Android 5. And a very important characteristic of JetpackCompose is that it's going to be backward compatible. So this is going to solve a lot of problems in terms of fragmentation Android, which has been like really a huge problem in Android development, that many apps required the latest or a later Android version in order to work. So with JetpackCompose, we don't have this fragmentation problem anymore because everything is going to be backward compatible. This is because actually you draw, you draw directly on the Android canvas. So, and Android 5 has already all the information about how to picture. So basically, JetpackCompose is just an external library of Android, similar to AppCompat and all these kind of things. So you just, when you develop an Android, you just need to, with Gradle, develop the latest version, and then, any device with Android 5 are able to have that UI update. So in iOS, things are a little bit different because SwiftUI is linked to the iOS framework. So this means that there's not going to be a backward compatibility. You still need to target a specific iOS framework. This really makes a little bit of a difference comparing to JetpackCompose. And then let's look at Declarative UI for the web. So actually, Kotlin has got the Kotlin language, not the Kotlin language, it's available in Kotlin. There are available some wrappers about React.js. So you could actually write a React app using Kotlin instead of JavaScript. And this is possible. We already have made some experiment and it really works, no problem. But there is something much more interesting which is coming up in terms of declarative UIs for web. And that is Compose for web. So Compose for web is basically JetpackCompose for web. So what exists, what is now developing for Android is going to be available for the web as well, with some modifications, of course. So development just started in last November. So the APIs are going to be very similar, if not identical, probably not identical, but really, really similar to JetpackCompose of Android. And very interestingly, in the future, it's going to be possible to compile for WebAssembly, which is the future of the web, as we know. So for the future, we can expect that in the end, we really are going to have like two big families of declarative UIs. We're going to have the Compose family made by Google and JetBrains, which are going to apply to Android, to desktop, which is already happening. Already with Compose, you can build desktop apps of any iOS, on any operating system, so Windows, Linux, or Apple, macOS. And then web, which is just coming up. And then we can expect that even wearable are going to be possible to write in Compose, or even TV apps. And with SwiftUI already, we can use seamlessly for iOS, macOS, watchOS, and tvOS. So let's have a look very quickly at some example of codes in JetpackCompose. So this is like a row, which is in Android would be like a linear layout, like a horizontal linear layout. So as you can see, the concept is really the same. So what you see here, these elements, this value row dot. So these are really fields which are coming from the app state. We're going to talk about the app state later. But you see what it changes between JetpackCompose and SwiftUI is really the syntax, but the concept is really exactly the same. So they are not defining any state; they are just applying the value directly on the layout. And this is, from this you can actually see that you don't need any extra layer to apply data. You can apply directly on the layout. Let's now talk about the second pillar, which is Kotlin MultiPlatform. So starting with a little of history. So Kotlin MultiPlatform started as an experimental feature of Kotlin 1.2, where the JavaScript web, the support for web was added. Then in Kotlin 1.2.20 in February 2018, there was the first support for iOS in Kotlin native. And in August 2020, with Kotlin 0.4, officially multi-platform reached the alpha stage. And then we expect, but we're not sure because JetBrains has not confirmed this, and it's probably not going to happen with exactly beta at Kotlin 1.5 or stable at Kotlin 1.6. But what I can say is that personally, I'm not really much concerned about what they are going to officially name beta or stable, because from my experience, Kotlin multi-platform is already very stable. And of course, there are going to be improvements, but most of these improvements are going to be under the hood. So this is not going to affect, in any case, your development, even if you start now. And then, maybe, with the beta, you're going to have, something which, but for them, we never really had big bugs at all, actually. It works really well already. That's very important. This is very important to make clear, because many people are not aware of this, of how well Kotlin multi-platform is working, but it is. I mean, it's flawless, to be honest, in 98% of cases. And then if we compare the timeline to the Declarative UIs, we can see that alpha in JetpackCompose was really happened at the same time with Kotlin multi-platform. And in terms of beta and stable, it looks quite certain, according to Google, I think, that this is going to happen. So by the end of the year, we are very, very likely going to have the stable version of JetpackCompose. And in SwiftUI, actually, the first version was already released like suddenly, with no really, unexpectedly, in June 2019. But if I have to be honest, the first version of SwiftUI was not that great. It had quite a few problems, which were fixed in the second version, which works much, much better than the first version, which was released last June. And we are probably going to expect even better improvement in the version 3.0. Okay. So talking about Kotlin multi-platform. So currently, Kotlin is able to target to compile for the 3 different targets. One is JVM, and we are used to it because of Android. JVM is also the target for the server side, because you can already, you can write Kotlin also for the server. Then you can target native for iOS, macOS, or for desktop like Windows and Linux. And then you can target JavaScript for the web. So our Kotlin multi-platform shared code has the form, in Android, has the form of a jar file, which is like typical, Android file. In iOS, it has the form of an Objective-C framework. and on the web of a JavaScript library, JavaScript file. So let's now try to compare the D-KMP architecture with Flutter and React Native. Okay, so in the D-KMP architecture, we're going to write our user interface, as we said, with JetpackCompose and SwiftUI. In Flutter, you write the UI using the Flutter proprietary widgets, and in React Native using their own proprietary widgets. In terms of business logic, in D-KMP, you write it in Kotlin. In Flutter, you write it in Dart, and in React Native in JavaScript. But the most interesting thing is to see how actually this code runs. So with D-KMP, we actually have a native Android UI and a native iOS UI. And in terms of business logic, as we said before, we're going to have a jar library for Android and an Objective-C on iOS. So you see, these are pretty native, like any app could be written in this way. So there are elements which are native to the platform, which is not the same in these other two frameworks. So in Flutter, the app actually runs as NDK on Android and LLVM on iOS. And the UI is actually based, for the UI, they're actually using the Skia graphic engine. And for React Native, you do have a native UI. Okay, that was like the main selling point of React Native. But then you have the code that runs is actually a JavaScript code, which is able to run thanks to a C++ bridge. So as you can see, if you compare D-KMP to Flutter and React Native, there is a huge difference in terms of how native it is. And in terms of performance, it's clearly much better as well. Okay, so one interesting thing to explain is that sometimes people get confused because they see so many acronyms about Kotlin MultiPlatform. And there are mainly two acronyms currently that are used for Kotlin MultiPlatform. One is KMM, and with this we mean Kotlin MultiPlatform Mobile. So we just mean Android and iOS. And actually now JetBrains released a very useful plugin for Android Studio for KMM, which allows you to run iOS apps inside Android Studio. This is so useful for development, like really. And then you have another acronym with a KMP, Kotlin MultiPlatform, where you typically mean everything. So not just mobile, but also desktop and web. Okay, talking about web, there is something very important which is coming up with Kotlin 1.5 in the second quarter of this year, which is the new JavaScript IR backend. This is going to bring a lot of improvement to the Kotlin JavaScripts. And specifically, it's gonna have a lot of improvement in terms of bundle size. And this is a very important milestone for KMP. And hopefully, we are really looking forward to see how effective web projects are going to be after this written in Kotlin. Okay, so suggested time to ship D-KMP apps. So we think for Android and iOS, it makes sense to wait for the second half of 2021. So waiting at least for JetpackCompose beta, even though you can definitely start designing, developing everything. So this is not a blocker to say that shipping should happen in the second half. And for the web, I think we should definitely wait for the IR backend and for the Compose for web, which we talked earlier. So 2022 roughly, but you can already start your development now. You can write your 85% of shared code, and then if you want to write the web app, you just need to add this 15% on top, hopefully using Compose for web, but you can do it next year. You're going to be busy in the meantime to build this business logic and to build this JetpackCompose and SwiftUI UI layer. Okay, so now let's talk about the third pillar, which is the MVI pattern. So this pattern can be seen as like an improvement of the MVVM pattern, which is very popular on Android, which is actually what is currently recommended by Google. So the main concept of MVI pattern is the unidirectional data flow and the single source of truth for the app state. So everything in an MVI pattern happens in the same direction. So the view, if the view wants to change the state, cannot change it directly, but it needs to follow the flow. So it means it should happen through an intent, and then through the intent is going to trigger an action on the model and is going to be the model. So the state can only, there's a single source of truth for the state, and that is only uniquely managed by the model. Okay, so let's go, let's see more in detail. So the MVI pattern has a single source of truth for the UI. So this is the architecture of D-KMP. As you can see, we have described the app state. So the app state is something which is managed directly by the view model and then is passed to the UI layer and is applied by any platform. So app state, it's basically just data. So, and it's multi-platform, basically. There's no anything platform specific in the definition of the app state. Very importantly, the app state consists of immutable data. And as we said earlier, it can only be modified by the view model. And so the unidirectional data flow you can also see from this diagram. So what happened is that from the UI layer, the user triggers an event or intent, you can call it, but yeah, we stick in the diagram to the keyword, to the word events. And then, so the event then is passed to the, so the events call the state reducer. So the events is actually code. We're talking about code here. So the events component, code component is calling the state reducer, and the state reducer is changing the app state. And then the view, so the app state then is passed to the view, and the view is applying the new state, which is reflected on screen. Yeah, so in our case, this MVI pattern in the D-KMP architecture is implemented, as we said, not via RxJava, but via something which is Kotlin specific and is StateFlow. So StateFlow is part of Kotlin Coroutine. It was released in May 2020 as part of Kotlin Coroutine 1.3.6. And as we say, it enables a multi-platform MVI without RxJava because it's actually part of Kotlin. So it works wherever Kotlin works, which is basically everywhere at the moment. And yeah, in our, it propagates, yeah, as we said, yeah, it propagates the state, app state from the view model to the UI layer. Okay, so let's have a look very simply, because I decided in the presentation, I'm not gonna burden with live codings, but I'm going to just present the relevant codes, because in my experience, whenever a presentation have live coding, it really distracts people and it doesn't really, it's not really able to keep the attention very high. So let's see what is the view model. So the view model definition. So what is actually a class, a Kotlin class, which has two properties, very important properties. One is the state flow, which is what allows the propagation of the app state from the view model to the declarative UI layer. So as you see in the definition, state flow is defined with app state as a type. So it's actually flow, making the app state, so it's propagating the value, which is the app state. And then the other component is the state manager. So one thing to notice in the state flow, you see, is a computed property, but only with the getter and not with the setter. This is because actually the state flow should be immutable, which is one of the characteristic, I mean, one of the requirement for the MVI pattern. So can be read-only. So for this reason, there is not a setter. Because it's actually the modification to the upstate are not actually made by this state flow, but they're made by another component, which is part of the state manager, which is mutable state flow. So the state manager is also a class, a Kotlin class, which has two properties. One is the mutable state flow, which actually what is able to modify the upstate. And then the data repository. You can actually see exactly the same thing from the diagram, because as you can see, you know, the state reducer. I mean, yeah. Okay, let's explain next step. And then what is the events? What are the events? So the events are defined as extension functions of the view model. So let's say an event is my click event, which is directly an extension function. So this means that it can, as you know, the view model is shared to all the UI layers. So it means that the UI layer can directly call the event simply by calling the function directly on the view model, on the KMP view model, which is shared. And what are the state reducers? So we define the state reducers as extension functions of the state manager. So similar concept. Yeah, so as you see, the state reducers, okay, no, we'll see in the next slide. What are the state reducers? Yeah, so the state reducer, what are the state reducers? So basically, they're something which are able to produce a new upstate. And to produce a new upstate, they do it by combining different inputs data. So one of the input data could be coming from the event. Some data come from the data repository, and then we are also, one of the input is definitely the old state, because we are actually just modifying. Okay, we are going to see in the next slide. Okay, actually, we are going to have an example now, which hopefully is going to help to explain much better the whole flow of an application. So let's say we have a list of elements. So this could be in any platform. It could be an Android app, or it could be an iOS app, or it could be a web app. So it's an app showing a list of elements, of items. So if we click on one of the items of this list, then we are going to call an event. In this case, it's, let's say, select city, which is actually, as we said earlier, an extension function which is defined on the share view model. And as you see, the UI layer, on the UI layer, you actually make this call to this, sorry, this, and then let's see how this event is defined. So this select city is defined as, you know, with two state reducers. Set loading. Okay, let's see the next slide. So the first state reducer, what it's going to do is just going to change a flag, which in this case is loading, which is turning it from false to true. So this new upstate is then applied to the UI layer, which then shows, you know, based on this flag, is showing a screen which is loading. And then we can asynchronously set the data which we retrieve from the data repository, and through another state reducer. And what is the actually reverting the loading flag to false, and then actually you know, retrieving and setting the detailed data that need to be shown in on the screen. So if you see in the detail these state reducers that we have been talking about, so the set loading state reducer, what is doing is just actually taking, so the mutable state flow dot value is actually the existing app value that already, yeah, that we see on top. And we are using this Kotlin function, which is called copy, which is basically duplicating the same app state with some modification. So in our case, we are just changing one value, one property, which is loading. So the other state reducer, which is setCity, is doing some more things. So is actually also retrieving the data from the data repository, and then is modifying the app state in both in two property, the isLoading property and also the detail property. Okay. So if we recap, what is the state reducer? So we say is an extension function of the state manager. And so it can take as inputs, it can use different data as inputs. One of the inputs come directly as a parameter of the function, which could come from the event. In our case, it would be the Berlin string, right? That is like an input which is coming directly from the UI. And then another input from the state reducer is actually the state repository that we saw earlier. The state repository is actually one property of the state manager. So yeah, as the state reducer is actually an extension function of the state manager, he has direct access to the data repository. And then the other input is the old app state, is actually coming from the mutable state flow, which is the value of the mutable state flow. And then we are able to create the new app state thanks to the Kotlin's copy function, which is just duplicating the same app state just with a few modifications. So it's a really interesting, very simple concept, but so powerful, amazingly powerful. Okay, so now let's talk about the data layer. So the data layer consists of a repository which collects data from multiple sources, which could be web services or any runtime objects or platform settings, platform services, SQLite databases, real-time, any kind of data. We don't make any distinction, because actually the state reducers, they just access the repository without knowing where this data is coming from. For the state reducer, it's just data. Then it's up to the repository to manage all the caching system, to collect the data from the courts to the relevant sources. So this is, the actual source is something which is managed by the data layer completely. Okay, so and then we are going to talk about a very interesting concept. I added these two slides today because it's a very recent thing. So in terms of web services, in KMP, we really need to think differently about it, because in the past, web services used to be the only shared code among apps of different platforms. For this reason, some business logic tended to be shifted to the web services. So for this reason, web services in the past, they really, it was probably the proper place to write some of the business logic in order to avoid duplication. But now in D-KMP, we are not in the same situation anymore, because web services are not the only shared code as used to be in the past. Because now we're going to have shared code also in the client, because the clients fully share their business logic. So some decisions that were previously made on the web services, some of the business logic that might have been on the web services, can now be fully made on the client side. And for this reason, GraphQL is a great fit for Kotlin MultiPlatform. So what is GraphQL? Hopefully you know, but is mainly, okay, I'm not going to, hopefully you know this, because I really don't have much time to explain, but is, simplifying, is something which is able to simplify heavily server-side development, where you're going to provide database data to the client. So it's really streamlining and reducing incredibly the development time when you want to access some data, some database data. And this perfectly goes in the direction of the rich client, because it's the client that can decide. In GraphQL, it's the client that decides which data. So it's not the web, like in the typical web services, actually the web services, you call a specific web service, and it's the web service who decides which is the data which is going to provide. So for this reason, you actually need to tailor exactly each web service to decide which is the data which is going to provide. With GraphQL, it's not like that anymore, because the server side is totally dumb. So it just has access to databases, but the actual data that you want to retrieve, it's decided by the client. And this really fits perfectly with a rich client architecture that we are really into. And so in this way, the server can just focus on data provision and availability and not at all in business logic. And actually, we have a client, a GraphQL client available for KMP, which is GraphQL Apollo client. But yeah, it's very important to notice that typically GraphQL makes sense only for data coming from databases, not from kind of other type of web services that take data maybe from real time or from external sources. Okay, so let's now show a simple table where we are talking about which are for each section, for each role, the libraries that have been used in the past and what will be used in the future with multi-platform. So in Android, the UI system used to be based on views and fragment, and in iOS used to be based on view controllers and UI kit. So in D-KMP, the UI layer is going to be based on Compose and SwiftUI. That's a very important, difference, as we already talked about in the previous slides. In terms of observable, we have already seen that in Kotlin MultiPlatform, we are going to use StateFlow, while in Android specific, it was normal to use things like LiveData, and in iOS, you would use things like Combine. So in terms of HTTP client, in Kotlin MultiPlatform, you can use Ktor client, which is the most famous HTTP client actually developed by JetBrains. Then in terms of serialization, also another library developed by JetBrains, which is Kotlin Serialization. For structured data, there is a library developed by Square, which is SqlDelight. For settings, there is a library called Multi-Platform Settings, which is developed by Russell Wolf, which is part of Touch Lab, which is the company of Kevin, which is watching us, hopefully still watching us. And then in the concurrency level, you can leverage the coroutines, like previously, like in the very beginning in Android, you use things like async task, and in iOS you would use Grand Central Dispatch. Okay, so this is the end of presentation. So it was probably 45 minutes, I think. So, and if you want to know more, okay, you can write questions, and I'm gonna look at the question that you might have. But then after this presentation, you can actually find much more information in a Medium article that I released a couple of months ago, where you see basically everything we talk about today, plus more things as well. And you can follow me on Twitter using my handle. Okay, this was all for this presentation. And now let's have a look if there are any questions. Okay. Compose can make 100%. What do you think? What do you guys think about Compose? Okay. I don't know what you mean. It can make 100. I mean, at the moment with Compose, you cannot write the UI for iOS, and it's not gonna come anytime soon, I think. So yeah, not possible at the moment. Will SwiftUI's lack of backward compatibility hinder adoption in production apps? No, for one reason, because actually this is not really, no, I don't think that is going to be a huge problem, to be honest, that fact. Because, yeah, I don't know how to explain it simply. Because, yeah, I mean, in any case, you know, each device, you know, Apple supports devices for 5 years typically. I mean, it used to support devices with the new OS system for 4 years, but actually this year, which was probably because it was the year of the pandemic and people had less money availability, who knows, they actually extended for one more year. So basically all the devices that support iOS 13 are the devices that support now iOS 14, sorry, are the same devices that supported iOS 13. So basically, they extended for one more year the support to the device. So if you think about 5 years of support for devices is not really that much. So for this reason, it could so you could actually target the latest iOS framework without many problem. I think it's not a big issue for the new versions to always target the new iOS version. Is there any UI designer coming with D-KMP? I mean, the UI you just develop using the native UI for Android and iOS. So in Android, you use JetpackCompose in Android Studio, and then, well, I mean, you don't need any UI design. You already have Android Studio, which has full support for the UI for JetpackCompose, and you have, you know, in iOS support for SwiftUI. The concept of reducer is similar to React Reducer. Is there library available for KMP? Okay, first question. Okay, so this is actually not a library, and this is very important to stress. So D-KMP is not a library, it's just an architecture. It's an architecture based on technology that are official. So it's based on Kotlin MultiPlatform, which is, I mean, okay, so you're talking about a reducer. No, in this case, it's not a library because we are actually using directly, you know, part of the Kotlin language. And actually, the definition of state reducer is really simple. So what you saw, okay, I try to go back to the previous slides. So the state reducer is just, okay, let's go to this one. Okay, no, I'm sorry. Sorry. Okay, so the state reducer is just an extension function of the state manager. And so there's not any library involved. So that's the beauty, because the Kotlin language gives us so much power already. And we actually can use an architecture that doesn't really have an external library. You can use fully what already Kotlin provides. That's the beauty of the thing. Okay, so then the other question is, have you considered using Redux instead of MVI? They are very similar. The main diff I see is lack of middlewares in MVI, where middlewares are responsible to communicate. It's lack of middlewares, where the middlewares are supposed to communicate with the repository from the web. Well, I think, well, it's already very simple like this. I don't know why you want to use something different, as you know, MVI is really made so easy by StateFlow in Kotlin. So I don't see how things could be simpler than that. I mean, if you do, you can write to me and we can think about. But at the moment, I think, I mean, look at this state reducer. Okay, this is a very simplified version, clearly. But the concept is very simple. So you are going to get a parameter. You have the chance to get parameter from the event, which is actually provided by the UI layer. Then with this event parameter, you're able to fetch data from the repository, and it's up to the repository to decide which is the source to take it from. And then you are just modifying the old state with the new data, and you have a new app state. So it's really simple. How has Apple approached D-KMP? Are they embracing it, or they want to keep iOS? So the point is that, yeah, maybe the question would be how Apple has approached KMP in general, I think you mean. Well, I think, Apple, if you think about Apple, they were never into the multi-platform concept. You know, they only care about their own technology. So for them, so they still use the multi-platform keyword, but actually they apply it to their own devices. While in Kotlin, when we talk about multi-platform, we talk about different operating system, which is, so the multi-platform concept of Apple is very different to the Kotlin multi-platform concept. So yeah, I mean, they don't care about anything else in Apple. So they don't know, they don't care about KMP. They just want to do things their own way. Yeah. Any other question? So would one compile a shared KMP project, then import into Android Studio? Okay. This is a very important question. I think I mentioned earlier, probably I didn't stress too much on it. Actually, using Android Studio, you can already run iOS apps. So that means that with Android Studio, you can fully develop everything already with Android Studio. So you don't need X. I mean, you actually probably need export for, you know, for a few things make sense, but definitely you don't need X. So with Android Studio, you have all you need to build this kind of apps and also to run iOS apps, which is amazing, which is something which is available only since August last year, but is working really well. So Android Studio is all you need. You don't, and Xcode for something, but not really. Less and less. I think Android Studio is going to be enough more and more, and probably in the future we would not need much Xcode either. Yeah. Okay. Welcome. Yeah, if you have any other question, I'm happy to, you know, even if you think it's a stupid question, don't worry. I mean, it's very interesting also for me to understand which are your doubts and which are your questions that come up after a presentation like this. So maybe it will help me also to improve my presentation to make things more clear. So is there an iOS AVD? So actually you are in Android Studio, you are able to use the Xcode simulator. So you launch it directly. So if you want to run an iOS app from Android Studio, you can actually even run you need the Mac. Okay, that's goes without saying. For development, you definitely need the Mac. You cannot do that with Windows. But yeah, you can actually run either your iPhone, on your iPhone, or on the Xcode simulator. Okay, so for this reason, you definitely need Xcode with the simulator for sure. How's testing support, especially in E2E or UI test perspective? Okay, so about testing, there is really nothing different than, you know, what is available already for Kotlin multi-platform. So on the Kotlin website, there is actually also a section about testing, and you can get all the detail there. So this is, testing is definitely going to be, is not going to be a big issue at all. And so yeah, but you know, if you want to know more, yeah, just look at the Kotlin multi-platform documentation, and everything is explained there. Okay, do you have a post tutorial GitHub repo with example? Okay, so at the moment, you can find more information in the Medium article, which I linked. You can Google it, but you can show it here. It's called The Future of Apps, Declarative UIs with Kotlin multi-platform, and it's actually a 3-part article. So at the moment, we haven't really published, yeah, thank you for sending the link, yeah. So at the moment, we haven't really published a repo because we're actually working on some commercial projects. So we didn't have, you know, we didn't have the chance to share them. But, you know, if you have any problem, you can really write to me. And if you have any question, and I'm really happy to help out with that. On that. Yeah, welcome.
Awesome.
Okay, Johnny, yeah.
Yeah.
Tell me if you think we should wait for more question or if it's okay like that.
No, I think we're right at time, so it's perfect.
Okay.
If folks have questions, they can always follow up with you afterwards directly,
yeah.
or they can send them to us. We're happy to sort of redirect them your way. And if anybody finds himself in Italy wanting to ride a train, now you know which app you should use to check
Great.
that out.